C of the bar rests against the smooth and horizontal and vertical surface. Determine the reactions that support A, B, and C. So JJ, is there anything given in the words that's not in the picture? No. So I'm just going to write given sketch. JJ, do find for me. So what are we trying to find?
The reactions of these force.
Right, reactions at A, B, and C. And since we drew them and used variables already, let's write the variables down.
BX,
AX,
AY,
AY,
BX, BY,
BX, BY,
CX, CZ.
and CZ. Great.
You wouldn't say that, given, because they did say that it
Yeah, the
was a
words.
forced reaction.
Yeah, you can put all that in there. That's Kelly has a good point that there were words that were defined that, gave us information. So yeah, you could write those too. I guess I try to make sure my given and find aren't so wordy. But you're right, if we didn't know that it only exerted forced reactions, we wouldn't have known that A and B were a ball bearing. You're right. Chris?
So about like the reaction, so like it has a little bit of give, so it does, so you don't consider it like resisting.
That's right.
But wouldn't that also, can you not have like a little bit of give in like the X and the Y just by themselves, just like a little bit also?
Yeah, but the give, you're gonna have very slight tolerances, so that it's just sliding right in there, but I understand what you're saying. So what Chris is saying is, if there's a ring of ball bearings in there, it can't spin the whole way, right? It could spin a little bit, and that means that it's not gonna break in that direction. But this way, it's still gonna break, right? Because you're resisting, even though you have a little bit of room, there's not much room.
Because it's center, it's not moving forward. The center part, it's just rotating, but it's not moving in that direction.
Say it again?
The center
sorry.
is not moving.
Okay, and which one?
It's only rotating at the bearing,
Okay, so at the bearings,
because there's no translation of motion. The center of it is not moving. It's like rotating. You got the bar. Yeah.
but I think what Chris is describing is that, usually there is, like, the fact that this bar can be in this hole means that there's a little space in there still. That's what you meant, right, Chris?
Well, no, you were saying that like the ball bearings allow for a little bit of like movement and for that as like a movement.
Only rotation. It doesn't allow this.
But it's not like the full rotation. It's like
It's
a
not the
little.
full rotation.
And I was saying like if you're able to like rotate it a little bit, wouldn't you also like if you were to rotate it, it'd be like kind of like this, right? And
Right.
So couldn't you just kind of give it a little bit like that? And so
No,
I'm just saying like if you have like a little bit of like allowance for moment, why does that mean that it doesn't resist a moment? Where if you have a little
Because
bit
it's a ball, right? So it's a ball bearing, so it could move like this, but it still can't move.
oh, those balls, they don't like compress.
No,
They're
no,
not,
no,
like,
no, they're
springing
steel,
down.
they're not, well, they could be other than steel, but no, they're not compressing at all.
Okay.
Okay, so let's do our table then. Okay, so Santiago, we're up to you. Okay, name the forces that are present.
What's the direct passage?
Yeah.
Maybe at the end of the bar, there are 400, 300, and 300.
Right. I'm just gonna put them all together, okay? They're all magnitudes given, their direction are given. What else?
And then the unknowns.
Right. So we have AX, we have AY, we have BX, we have BY, we have CX, and we have CZ. And the magnitudes are all unknown, right? How about the directions? No. So how many unknowns do we have total? 6 unknowns. How many equations do I need? 6 equations. It's a 3D body, so how many bodies do I need to analyze? 1 body. So the question, Santiago, you had earlier is, well, aren't those forces creating moments about points? And yes, they are creating moments, but we're going to stop them because it's a statics problem. But I don't list them in my table because there are not concentrated moments and there are no moments that it can resist. Okay, so we know what our equations are, right? Let's think of some of the forces in the x. Some of the forces in the x, how many unknowns are going to be in that equation? 2. Ax, no, actually 3, right? Ax, bx, and cx. That sounds like a horrible equation. Okay, how about some of the forces in the y? 2. How about some of the forces in the z? 1. Woohoo! Which equation do we want to do? Some of the forces in the z. Jill, go up to the whiteboard, grab a pen, sorry. I saw more white in her eyes than I have ever seen. Grab a pen, go do the sum of the forces in the z equation on the whiteboard. So go on this one. Go on that one since that one's clean. So sum of the forces in the z equal.
You don't have mass of the bar?
So erase your 0. Let's put the 0 at the end. Nope, we're ignoring weight. So what do we have? What forces are in the z? CZ, and it's going in the positive direction. Wait, keep going. Let's see. Are there any other forces?
Oh, it's good.
Right.
That's it.
Right. Equals 0. So CZ is equal to? And box it in. We're done with that one. Okay. Okay, so now let's look at the sum of the moments about the x-axis. Does AX, Eric W., does AX and BX create a moment about x?
No.
Does the 400 create a moment about x?
No.
No. Why?
Parallel.
Right, all three of those are parallel. AX, BX, and 400 don't create a moment about x. But how about AY and BY? Do AY and BY create a moment about x?
Yeah.
Yeah. How about CZ?
Yeah.
Yeah. Okay, let's look at some of the moments about Y. Okay, Brandon. Some of the moments about the y-axis. Does CZ create a moment about the y?
No,
Why?
because it intersects.
Intersects. How about CX?
No,
Why?
because it intersects.
Okay, how about AY, BY?
No, because it's parallel.
Parallel. So let's make a big old table. So forces, and they're in newtons, right? Moment about x, moment about y, moment about z. So it must be Newton. Is it meters or millimeters? Millimeters. Let's just use the millimeters that are given instead of changing them. So we're doing another 3D right-hand rule problem. So how many forces do I have? I have 5 of them, right? No, I have more than 5, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9. That's the right timing. Okay, so we have AX, AY, BX, BY. We have the 200, we have the 300, we have the 400. We have CX and we have CZ.